Hi, and welcome back to Chapter 2. Today we're going to work on multiplication. So we have to remember back to Chapter 1 and the rules that we learned there. So remember that the rule that we talked about when we multiply like bases, we add exponent. We're going to bring that rule in here. We're going to go ahead and be working with some monomials times monomials to start. Remember from the last section that a monomial simply means a single term times a single term. So when I'm putting these together, I put like things together. So the 4 is going to multiply with the -8. The x cubed is going to go with the x to the 5th, and then there's nobody to go with the b squared. So 4 times -8 is -32. X to the 3rd times x to the 5th. So remember, we add exponents when we are multiplying bases that are alike. And then the b squared is all by its lonesome. So it's 32x to the 8th, b to the 5th, and proper mathematics is to do letters alphabetically, so it should be b to the 5th, x to the 8th. So the next one, 5 times 8. Now a squared, there's no other a squared, so that's not going to do anything. X cubed with x to the 4th, and we have a b squared that's also by itself. So 5 times 8 is 40. A to the 2nd, because there's nothing there. X cubed, we're going to add the 4 from the other one, and then I can't forget my b squared. So I add the 3 and the 4 and get x to the 7th. And again, I'm going to write it properly. So a, then b, and then x. -6 times 4, x with the x squared, y with the y squared, and nobody's with the z. -24, this time I'm not going to write it all out. Remember, this has a 1 because it doesn't have any exponent written down, so we know it's a 1. So 1 plus 2 makes 3. Again, 1 on the y plus 2 makes 3 for the y. The z's hanging out. And this time they're already in correct order, x, y, z. So as we move on down, we're going to make it a little bit more difficult, just in the fact that we have more terms. So we have a monomial, single term, times a 1, 2, 3 trinomial. Now the process isn't different, you just do it more times. So I'm going to do this -a squared b cubed times the 3a to the 4th, and then I'm going to times it with the 6abx, and then with the -4b to the 4th. So first one, -8 times 3 would be -24. Now I have a squared and a to the 1st, so 2 plus 1 makes 3. I have b cubed and no b's here, so they would go next. And I have x's in my term inside, but no x's outside, so they'll just tag along. So there's my first term. So I've done 1/3 of the problem. Now we're going to do the second third. So I'm going to take -8a squared b cubed times 6abx. And I'm going to switch colors just to help us see. So now I'm doing this one times this one. So -8 times 6 is -48. A to the 2nd times a to the 1st. There's an invisible 1 there. 2 plus 1 makes 3. B to the 3rd times b to the 4th, or sorry, b to the 1st. There's a 1 there, so 3 plus 1 makes 4. No x's, but there is an x on the inside, so it's going to tag along. So now we'll do the last one. So we're going to do -8a squared b cubed times -4b to the 4th. -8 times -4 is a positive 32. A to the 2nd, no a's, so they just tag along. B to the 3rd, b to the 4th, 3 plus 4 makes 7. And that's it, that's all the variables. Now, we might be done, but we have to double check. So we want to look at these 3 terms and make sure that none of them are alike. So I have an a cubed and an a cubed, a b cubed, b to the 4th. Since the b's have different exponents, these two, the first one and the second one, are not alike. And when I look at the third one, it's an a squared, which is automatically different than the other two, so this is our final answer. It is a trinomial. So now when I go to B on these examples, I have a 1-2 term, which is a binomial, times a 1-2 term, which is a binomial. So I'm going to do x squared times x. So there's an invisible 1. The 2 plus 1, I get x cubed. Now I still have to take this, I'm distributing it, so it's going to be x squared times the first term, x squared times the next term. So just like on A when I distributed it and I had to take it times everybody, I'm doing the same thing down here. X squared times x squared times c. So doing it with the letters in alphabetical order, c would come first. So I've done the x squared by both of the 2 in the next one, so that one's done. Now I have to do b times x, so I'm doing the distributive property with the b, and then b times c, and there's nobody left, so I'm done. So I look at these and see if anybody's alike, and there's nobody that's alike, so I'm done. So on C, I have another binomial times a binomial. So y squared times y squared. 2 plus 2 makes my exponent be 4. Y squared times negative 4. Negative 4fy squared. Now I'm going to switch because there's nobody else in the second one to multiply by. So I'm going to do 3f times y. So it's 3fy, and that y is squared. So this is definitely squared here. Now I'm going to do 3f times negative 4f. 3 times negative 4 is negative 12. I have an f to the first and an f to the first, so 1 plus 1 makes me my f be squared. So I'm going to look across here, and at this time I see I have an fy squared and an fy squared, so I do have some like terms. These are like terms, so I do want to combine them. So I have negative 4 plus 3, so that's a negative 1. Now you don't necessarily have to write the 1, I'm just putting it there to show what's going on. And nobody else is like my y to the 4th, so it's going to just tag along down below. And then nobody else is like my negative 12f squared. So there's my final answer. So here I have a monomial times a binomial. So I just have to do this process twice. 6 times 8 is 48. No other x's, so the x tags along. No other y's, so the y tags along. 6 times negative 7 is negative 42. And the 7 doesn't have any variables, so my x for my 6 will tag along. X, y, and x are different, so since they're not like terms, I am done. Okay, just a couple more examples. So on this one on E, notice we have some negative exponents, but we're not going to do the process any different. I have a monomial times a polynomial. Anything over 3 terms is simply a polynomial. So I'm going to do the distributive property one at a time. 4 times negative 5 is negative 20. I have a y squared and a y squared. 2 plus 2 becomes 4. 4y squared times 2y. 4 times 2 is 8. Y squared times y to the first is y to the third. 4y squared times negative 5. So the 4 times negative 5 is negative 20. The y squared tags along. 4y squared times 3y to the negative 1. 4 times 3, that's 12. Now I'm still adding exponents, so I'm adding a 2 and a negative 1. Well, 2 plus negative 1 is just 1. So this is y to the first. Now you don't need that one, I'm just showing it so you can tell what I did. So it's 4y squared times negative 6y to the negative 2. 4 times negative 6 is negative 24. Now I have a y to the second and y to the negative 2. 2 plus negative 2 is 0. Since that's 0, I don't have any y's left in my last term. So let's see if we have any like terms. I have a y to the fourth, y to the third, y to the second, y to the first, and no y's. None of them are the same. So I am done. I still have a polynomial. Now f looks a little bit different than all the rest of them. I really only see one parenthesis, so I have to think about what does the squared mean. The squared just means I have two of these. So what this problem is really looking like is it's x minus 5, and I have a second one of x minus 5. So it's saying I have two of the exact same thing. So now I do it just like I did on C. So I'm going to do x times x, and that's x squared, x times negative 5, so it's negative 5x, negative 5 times x, negative 5x, negative 5 times negative 5 is a positive 25. Now as I look at this, I see my middle terms are the same, they're both x. My first term's by itself, negative 5x and negative 5x is negative 10x. 25, there's nobody else like it. So I am done. Okay, last one we're going to try in this multiplication section. So again, I have a binomial times a binomial. So I have xy times xy. Now this one might seem a little bit tricky, so I'm going to write it down here for a second. I'm doing xy times xy. Well, if I look here, I have two x's and two y's. So when I do xy times xy, I really get x squared y squared. A lot of times when people see this, they think they only put the 2 after the y and it counts for both, but it doesn't. You have to give each one of them a squared. So now I'm going to do x squared times 3. That would be 3xy. Now I'm going to do the other term. So negative 3 times xy is negative 3xy. Negative 3 times positive 3 is negative 9. You can see my middle terms are like as they were on f. My first term, nobody else is like it, so I just rewrote it. 3xy minus 3xy, well 3 minus 3 is 0, so that means I have no xy's left. And then I'm just going to subtract the 9. And those are not like terms. So in this case, my binomials ended up with a binomial, where in f, my binomials ended up with a trinomial. Just depends on what the scenario is. So that's the end of multiplication, and I'll see you next with division.